Welcome back to the channel, everybody. So, we're continuing on the kick of Thundereggs, Lithophysae, these things, okay? Today I wanted to talk about this image right here, which you may have seen in the past. I certainly see it come up here and there on the correct way to cut a Thunderegg. Now, I didn't fully understand where this image came from or the context related to it until I got the book that the image came from. And context is everything, right? So the book is called The Formation of Thundereggs, and it's by Robert Colburn. Great book, very in-depth, okay? It's 500 pages of just talk of Thundereggs. And so Lithophysae, these things occur all around the world, and it is very complex. We've touched on the basics here on the channel in the past, which is good. Basics are good. I'm not going to get too in-depth into all of, these things occur all around the world. They've been immensely studied, and, there's some junk going around the internet where people are like, we don't know how these things were formed. It's a mystery. No, we know exactly how they were formed. Just because you don't doesn't mean other people don't. So, that said, we're not really talking about the formation of these. We're talking about that picture, the cutting aspect of it. So for sake of conversation here, I will be using words like the right way, the wrong way, the correct way, the incorrect way. And really what that's referring to is the way in which you would cut a Thunderegg like this one, with geometric pressure ridges, and we'll go head over to the whiteboard here in a minute, and we'll talk about geometric pressure ridges, so that the correct way is to cut it in a manner that exposes all of the phases that the Thunderegg could have gone through over time. If you're curious what these inside of these things will, they can look like. They can look like a lot of things, right? We've shown them here many times on the channel, but let's head over to the bench. We're going to talk about geometric pressure ridges, talk about what to expect when we cut this, and then what I want to do is we're going to cut it the right way, and then those two halves, we're going to cut those again, and then cut those again. So we should end up with 8 about equal pieces, and then we can piece it together, take a photo, reassemble it in another orientation, take a photo, and see what the other orientations of this Thunderegg actually look like. So before we look at the whiteboard, I want to show you the Thunderegg that we're going to be cutting. This is a blue bed Thunderegg from Richardson's Ranch in Central Oregon, and this does have geometric pressure ridges that I've highlighted with red on here so that you can see how we have a line that runs all the way around on the top and bottom, with some lines that connect. I think you can see here now that Thunderegg in question with those red lines drawn on it. Okay, so that is the representation here. So the orientation of this is such that we would want to cut it. We want to cut it like this. So a saw blade moves into it, and we cut it in half like this orientation, right? Doing so means that we will cut through as many phases of the development of this Thunderegg as possible. So a prime example of that would be if opal filled in the bottom, and then some water line, and then there was a gas event, and it, we have fortification, and then it just filled up, right? So that's basically it. If you were to cut across the top of it, let's say, you might miss some of those events because they take place at the bottom because of gravity. So that's kind of the idea here, is to be able to orientate the egg in a way where we know what the top and bottom is based upon gravity. And that is the correct way. So there is that. Now with this Thunderegg, if we were to pull all this rhyolite off, it would probably look something like this on the inside. The green being the agate that has filled this gas bubble. A good example of that is right here. This being a pretty good example of that. Now, they're not all going to look perfect like this, right? That's just the way it is. And there's so many Thundereggs. This is only applying to this one. Here you can see one that is not cut correctly, just kind of like whacked across it. So if you had a waterline building event here, you wouldn't see it. I'll show you an example of that. So this Thunderegg, I just kind of whacked it in half at an odd angle, and this is what we end up with. Now, all Thundereggs, for the most part, look really good when cut. But did I miss something? Is there something not visible with this method? Possibly. You can see those pressure ridges, right? So we have a little point here where it expanded all the way out, and we have a pressure ridge, okay? So where you see these pressure ridges, that is likely where there's going to be agate, like right at the, I guess, the skin of the Thunderegg, close thereof. Sometimes you can see it, sometimes you can't. So I'm going to orientate this the correct way, and we'll make our first cut on it. So here is the cut Thunderegg. After it came off of the slab saw, I took it over to the Richardson's high-speed sander and just took it up to an 80 grit, so it's a little less rough when we look at it. And here we go. You can see it just kind of has that matte finish on it. And we have a number of interesting things going on in this Thunderegg. It's fairly well formed. You can see right there on the left-hand side, well, both of them, down by that water line banding, well, you have some chips. That's unfortunate. We could absolutely grind those out if we so chose, but this is a learning experiment Thunderegg, so we're only going to be doing so much with it. But there's a lot that I think we can learn from this. So let's look at the whiteboard for a sec. So I kind of drew the Thunderegg out a little bit. You can see how our pressure ridges exit or come to the surface kind of the Thunderegg. We have a waterline building event. So this was the bottom, right? So, you know, gravity. And then we have a pressure event represented in red, where we do have some light fortification. And then we have some more water banding filling up that void, and that is, we cut it the correct way so that you can imagine now, right? If we were to come in and if we cut it this way, right, you wouldn't see any of this. This would just be hidden. So this way, the correct way, did in fact expose the maximum amount of Thunderegg. There is one feature in here that I want to point out, which I think I know what it is. And in the next cut, we'll probably have a much better idea as to what it is we're looking at. So you can see right above that water line, right there, if we can focus, almost looks like a piece broke off and then was reformed into it. I'm pretty confident that's what happened. And I'll show you another Thunderegg I have, and it's this one. And if you look at the angle in which it was forming, well, we have a big void back there. So I wonder if our waterline building, how that's going to look different as we cut into this. If that was like a little peak somehow. Like, was the egg actually kind of like sitting in, obviously that's down, but was it tilted a little bit? And that's what we're witnessing. All that's left to do is we're going to cut these and then cut these, and we should have a much better idea. So I'm going to head over to the trim saw now, and I'll start cutting these. I have a Thunderegg now, cut into 4 pieces, correct orientation, and then I guess you could say the opposite orientation to that. I don't think I'm actually going to cut it anymore. You can see that some of the rhyolites starting to crumble off, and I don't want it to just break apart. That's not going to help me any here. So once again, we have our correct orientation with the water lines down, okay? And then if we flip it, you can see this, and there's a clearly this is probably not as good. And I mean, what's neat about a Thunderegg is what's inside, and exposing that in a way that shows the geological history of events that took place with it. The waterline banding at the bottom, different events going up possibly. Now that's, it's one thing to look at a diagram in a book. It's another thing to make it and kind of like see them side by side, which is pretty cool, I think. It does make me wonder how many Thundereggs have been cut where somebody just slapped it in their saw and cut it and got that as opposed to that, which is cooler. So interesting way to think about it. I am, from now on, going to attempt to determine the top of a Thunderegg when I'm digging Thundereggs. So, you know, a good example of that would be if there's some way for you to determine that, let's say, a clay layer that trapped the gas bubbles that these things formed within, that clay layer is now tilted like this, so your Thundereggs are like this, coming out of it, this being the top up here. I'll just mark them with a Sharpie. I'm just going to mark all my Thundereggs with a Sharpie so that I have some type of visual reference for later on, so that I have an idea as to, well, what the top was. Well, I think that about wraps it up here. Thanks for coming hanging out with me in the shop. It's always fun to test stuff out, learn things, all of that good stuff. Go check out the website, currently rockhounding.com, and I will catch you guys on the next video. Thank you.